Good day to you, wherever you are watching me from. In this video, I will be explaining the t-test analysis as well as the simple guide to actually interpret the results or outputs when we run SPSS when we run t-tests on software like SPSS. The first question we are answering is, what is t-test? A t-test is a fundamental statistical method. You can refer to it as an estimator that is used to compare the means of groups and determine whether the observed differences are statistically or simply due to random variation. For example, now, if we have two tubers of yam and you are using your hand that are almost similar to check whether which one is bigger, the chances are high that there could be error in your judgment. But when you have a scale, the scale will tell you that this is greater than this by so and so gram or kilogram. But in the instance of two groups, their mean may be greater than one another. There may be difference in their mean, but it is t-test that will give us the information whether the difference observed is statistically significant or it is not. So this test helps researchers to make evidence-based decisions by quantifying the probability that differences in sample means reflect genuine population differences rather than sampling error. And there are three types of t-tests. We have one sample t-test, we have independent samples t-test, we also have the paired sample t-test. You see, the one sample t-test, just like the name, one sample, the researcher samples only a population, and when that population is sampled, the mean of that sample is actually compared with another sample that is fixed, the fixed mean. It's not that they took the sample, it's not the researcher. So in one sample t-test, there is a mean that is gotten through primary, which is a primary data, but the second mean is a secondary data. It may be a national average. It may be the mean score of last year UTME, if we are comparing it with this year own, or the average mean score of UTME in the last 10 years. We are now comparing it with this year on. So one sample t-test, data gathering takes place only in one, and the other group, there is no data gathering. The second is independent sample, whereby we compare means between two distinct unrelated groups. So there are two populations. We sample A, we get the mean for the construct we are looking for. Then we also sample B and get the mean for the construct we are looking for. Then we compare. The next one is the paired sample t-test. In this one, there is a comparison of mean from the same group at different points of time. Let's say somebody is started exercise because he's obese or she is obese, and we now took the weight at the beginning of the exercise. After 10 weeks of exercise, we check the weight again. We are pairing the two weights over different time. That is the paired sample t-test. So the purpose of one sample t-test is that it determines if a sample mean differs significantly from the population mean or theoretical mean. So one sample t-test, we can say that we want to check whether the blood pressure of the average blood pressure value of people in the age of 40 to 45 to a group. Literature has told us that the blood pressure of people in 40 to 45, let's say, is 130 mm to 80 Hg. So we now want to determine if that is comparing to a group of people in that age bracket. So you can see example scenario: compare average student exam score to a passing threshold of 50. So the research question for that will be, do students score significantly exceed the minimum pass mark? So that minimum pass mark is the fixed one. So in one sample, one of the mean that we are comparing with, the standard mean, is actually fixed. So the next one is the independent sample t-test. This test compares the means of two separate independent groups. We can see that they are backing each other. It could be male and female, to determine if there is a statistically significant difference between them. For example, comparing male versus female student performance, testing treatment versus control group outcome, examining differences between two teaching methods. So the next one is the paired sample t-test. And this one, we usually have a pre-test, initial measurement before intervention. We have treatment application on the same sample, the same population, from the same population. And then we have the post-test. We want to check now. So we want to check whether the treatment has effect. I have explained it. So it's measuring what is taking place over. So that is the paired sample t-test. So I want you to understand the way the hypothesis of the t-test is always tested. You can use the null form. For example, there is no significant difference between the group means. Any observed difference is due to random chance or sampling error. Example, male and female students have equal average score. That's a null hypothesis. That means they are the same. But in the alternative hypothesis, we can say there is a significant difference between the group mean. That means the observed difference reflects a genuine population effect. Male and female students have different average score. So that is how we usually state the hypothesis. And when you run it on SPSS, which we will do in another video, it is important that you recognize that there is a mean average value for each group, providing the central tendency that is being compared. So we will also say, oh, the first thing we will talk about is that the mean of group A is this, while the mean of group B is this. Then the t value, test statistic indicating the size of the difference relative to variation in the data. Then you will talk about the degree of freedom. Then you talk about the p-value for the significant two-tailed test. These are the three things to look for when we are doing t-test analysis. The next thing is, how do we decide? The rule is that when p is less than or equals to 0.05, we reject the null hypothesis and accept the alternative hypothesis and conclude that there is a significant difference. When p is greater than 0.05, we fail to reject the null hypothesis and we cannot accept the alternative hypothesis. We only conclude that no significant difference. The 0.05 threshold represents 5% risk of type 1 error, falsely rejecting H0. So this alpha balances type 1 and type 2 error rates in most of the research contexts that we have. So I want to interpret. So this one, P is 0.03. I will just decide that there is a statistically significant difference between the groups because the observed difference is unlikely due to chance alone. Example 2, not significant. So let's say the p-value in the example 2 is 0.12. It's not clear, but it's there. The decision is that it is not significant. I will just say no significant difference between the groups, p greater than 0.05. The observed difference could reasonably occur by chance. So that is the simple way to do t-test analysis. In the next video, I will be computing t-test for some set of data, and I will also interpret. Thank you for joining this video, and I want you to like and subscribe to our channel.